All right, well, hello physics students and welcome to this video lecture that's going to be going through work, kinetic energy, and then the connection between work and kinetic energy. So jumping right in, what is work? We say that work is done when a force causes a displacement of an object. So that is our verbal definition for work. Now, we also have a mathematical definition, just like with anything in physics, and that mathematical definition, we say that work is equal to force times displacement, okay? Now, our units for work, well, if we can break this down a little bit, we know the units for force are newtons, and that's times our unit for displacement, which is meters. So we could just say that the work units are newton times a meter. However, we simplify that down in physics and we say that the units are joules, and we abbreviate that with a J. Now, there's some different kinds of work that we can have, and this is going to be this next portion here, the important work concepts. You should have seen today that we can have positive work, we can have negative work, and we can have zero work being done. All right, so our big three rules here are important work concepts. The first is that positive work is done when the force acts in the same direction as the displacement. So if we have a force being applied this way, and that object is being displaced in that same direction, that's positive work. Next, we have negative work done when the force acts opposite to the direction of the displacement. So if we have a force acting back this way, and we have some displacement going to the right here, then that is negative work being done. And then finally, we have zero work done when forces act perpendicular to the displacement of an object. So that would be looking like this, and our displacement is that way. There we have zero work being done. So we're going to be delving in deeper with some examples of these different types of work. But now on the next slide, I'm going to be discussing kinetic energy and how work and kinetic energy are actually linked together. All right, so moving on from work. The next component to this video lecture is going to be talking about kinetic energy. Now we're going to talk more deeply about kinetic energy towards the middle part of this unit that we're in right now. We're going to talk about a bunch of different types of energy. But for our purposes right now, we need to know what kinetic energy is. And kinetic energy is the measure of an object's energy based on its motion. So if an object is moving, it has some amount of kinetic energy. Now, our mathematical definition for kinetic energy is that kinetic energy is equal to 1/2 mv squared, okay? And our units for kinetic energy, like work, are joules, okay? We're going to see that units for all types of energy are joules. Now, I could break this down as to why the units for kinetic energy and energy in general are joules, that they equal work, but not in this video lecture. Maybe sometime in class we'll derive those units. So, how are work and kinetic energy actually related? We know just from this definition that if an object is in motion, it has kinetic energy. Now, we need to be aware of, when we think of kinetic energy, when work is done. Well, work is done when a force causes a displacement. And we know that forces cause changes in motion or acceleration. So if there's work being done on an object, well, that object's motion is being changed. Okay, so what we can say then is that the total work done, or work net, is equal to a change in kinetic energy. And this change in kinetic energy is just our kinetic energy final minus kinetic energy initial. Okay, now we can extend this expression out a little further, and we could say that net force times a displacement is equal to 1/2 mv squared, mv final squared minus 1/2 mv initial squared. Okay, so notice that right here, this is just our work equation, and then this corresponds to our final kinetic energy, and this corresponds to our initial kinetic energy. Now, these two expressions, well, mainly this guy right here as a whole, this very simple one, we call this the work kinetic energy theorem. Okay, this is our link between work and energy. Now, I want to take a closer look at this work kinetic energy theorem and give us some triggers so we know what happens as a result of something else. Okay, that sounds really vague, but it'll make sense in a second here. So I want you to imagine that you're in your car, you're at a stop sign, and you're set to go. So you hit the accelerator. Well, you are applying there a positive force. Okay, you have a positive force, and you're applying that over some displacement. So if you're applying a positive force and you are at rest, we know that because of that positive force, you have to be accelerating positively. So you're changing your motion. So if we have a positive force, we have positive work being done, and that causes an increase in kinetic energy. Okay, because you started from rest, that positive force is being applied, so positive work was being done, so therefore your final velocity was greater than your initial velocity, and therefore you have an increase in KE. Now, conversely, let's say that you're approaching a stop sign and you hit your brake. Well, if you hit your brake, you have a negative force which is applied over some displacement, so that's negative work. Now, if you have negative work being done, that's actually going to cause a decrease in KE. Okay, and just think about that. When you hit your brake, you slow down. So you had some initial velocity, but you end up at rest. So if we have negative work being done on an object, we actually decrease our kinetic energy. So right now, this is a lot of information to be thrown at you. You have work, you have kinetic energy, you have these two mashed up together. We're going to be continuing to apply these things throughout the next few days, right up until our final. So I hope that this tutorial kind of solidified some things that you might have seen in class today. And with that being said, take care, physics students.